Well, it's kind of interesting how ideas seem to float around and then people pick them up and so on. I kind of was planning to come and present this thing as more of a proof of concept, just an idea to see what people would think of it if they would be interested in this path of functional testing. And it so happened that I asked a guy if he could review my slides, and he said, hey, did you see that Hunter actually has something similar in his, on his GitHub account? And then I went to Gareth's talk this morning. Who's been to Gareth's talk this morning? Yeah? I have to warn you, there's some ideas that kind of are similar in there, and we haven't talked about it at all. I never shared with Gareth about this. And just as he was saying that he was just throwing ideas in there and questioning some things, you know, this is pretty similar, except I think we have some things that may be complementary. I hope so. So who am I? My name is Raphael Pinson. I'm French. I work from France, and I'm an infrastructure developer and a trainer at Camptocamp. So yeah, you may know Camptocamp from our modules. We've been using Puppet since roughly 2007, 2008. And I mostly spent the last year doing Puppet Labs trainings and development around Puppet. I'm also an OGS. We're still fighting over how to pronounce the name. I say OGS. OGS and OGS providers developer. Who's never heard of OGS before?
We went round down.
No. Okay, cool. So I'm an OGS developer, an OGS providers developer, and I'm actually really excited that we released version 2 of OGS providers just last month. I would have loved to do a talk on this, and it's not happening this way, but I'm also excited that just as in the beginning of this week, the approved modules on the Forge were announced and all the OGS providers modules are included, so that's pretty cool. And yeah, and in the last mostly 2-3 years, I've been doing quite a few contributions to Puppet and its ecosystem. So what's this idea of functional testing, orchestrated functional testing? It's kind of funny. I didn't change this slide today. So as I was following Gareth's talk this morning, it was like, is this monitoring? And I so happen to have the same kind of question. Is monitoring and functional testing, is it redundant or is it complementary? And I firmly believe, but I'm not really a monitoring expert. I'm not a lot into monitoring, but I firmly believe that we may be trying to do too many things in monitoring. Maybe there's some things that we should offload of monitoring and we should just focus on checking the services, and then some of the things should be done as functional testing. Typically, well, checking if a package is installed, checking if a user is present, maybe even if a port is open, you know, things like this. And you may tell me, well, yeah, okay, but you know, if I told Puppet to install a package and it actually applied the catalog without an error, then the package is there, right? Yeah, hopefully it is. There's some cases, you know, that happen, like for example, you have virtual packages, and you actually told Puppet, yeah, this you know, this package foo is providing the package bar that you're asking me for, so there's no need to install it. It's already there. But you actually wanted package name bar to be installed, and it's not there. Puppet is happy with what's happening, you know. Puppet is happy with what the provider actually said, but the package is actually not there. So the state that you wanted on the machine is actually not present. Same could happen with services, for example. Puppet is happy. It actually started the service. It thinks the service is actually started, but it's just that the init script is actually buggy and the service is actually not running. And if you could have functional testing, you would actually see that the service is not running. So I do think that it's quite complementary, and there's some tests that you would like to run mostly when you have changes, and maybe once a day, or at least not every 2 minutes. And that would offload a lot of things from the monitoring infrastructure. So that's what I initially called conformity tests, but after actually hearing about Hunter's project and hearing Gareth's talk this morning, I would be willing to call this more like policy enforcing, let's say. So some tests that are more around policy. And the idea is, well, to check if machines comply to standards, avoid permanent heavy monitoring checks. A lot of things are done in monitoring that don't need to run every 2 minutes, really. And tests that are interdependent. And I'll give some examples afterwards. And the idea would be here also to focus on getting systems to fix one thing at a time to converge towards a target state as far as policy goes. 6 years ago, I was already using Puppet personally, but I was not using Puppet in the company where I was working. For some reasons, the managers didn't see the point in actually migrating from CF Engine 2 to Puppet. They're still stuck with CF Engine 3 to this day. And I already saw this need, but I didn't have the Puppet and MCollective tools to work with. And so I wrote a tool, which at the time was written in Perl. I'm sorry for this. And it was a very monolithic tool, and it didn't use any orchestration like MCollective. The idea was to orchestrate conformity tests, so let's call it now policy tests, on a 4,000 plus server fleet. And what I meant here by conformity or policy test, we're typically checking for things like, okay, let's see. I'm taking the servers from a centralized database. Let's call it a CMDB. In this case, it was just a database with the name of the physical machines that we had installed, because we didn't do much virtualization at the time. And I wanted to check first if the name of the machine actually resolved. Was it recorded in the DNS? There's no point in going further if that is not true, right? If there's no DNS resolution, I know I'm not going to get anything else. Second step would be, is there reverse DNS resolution? And once I had this, I could check, well, do I get information? We had a tool that was pulling information in XML from all the machines every night. Do I have this information from last night? And if that's true, then I can do actually more tests. Is the machine up to date? Is the machine backed up? Does it have proper sources lists for apt-get and things like this? And so as it went, we had these tests that were interdependent and that are represented by the thing here. So what you have here was generated by this tool, and this tool is not open source, but it's just to give you an idea of what it was. So up there, the little square up there was the database with old machines, and then you had filters that would get these machines, filter them, and put them into the tests. And the tests are all these, how do you call this shape? Elliptoidic kind of shapes, right? These are all the tests, and they are interdependent. And here on this one, I cannot zoom really much, but what this would say is the name of the test, the dependencies between the test, and how many machines had passed the test. And if a machine wouldn't pass the test, then all the dependent tests wouldn't be taken. If a machine doesn't have DNS resolution, again, there's no need to check if it could be backed up. And the idea was that here you would have a global view with all the machines and how many percentage of machines actually passed the test. And then there was a view per machine, which had the same test, but with different colors. So green is a test that actually passed, obviously. Red was a test that didn't pass. And purple was a test that wasn't taken because the dependencies were not met. And the whole idea of this was that a systems administrator could just look at this picture for a machine and look at the red stuff, click on one, and get documentation for how to fix this one. And then he would fix all the red for a machine on one day, and the next day, the dependent test would be ran with new instructions if they were broken until all the machines were green. And when all the machines were green, we just added more policy to enforce more things. And this way, we converged towards more standards in the data center. Machines that were always backed up properly, that had homogeneous apt-get configuration, and so on. So that was the idea at the time. The architecture of this tool was quite monolithic and centralized. It used data from a database. So that was a MySQL database that had our machine centralized information with actually the physical machines. The test script actually outputted YAML, so they could be contacted either locally by throwing stuff into the standard input, or remotely using HTTP with a post, so you just posted the name of the machines and got a YAML as a response. And the tests were interdependent with a YAML configuration file, and it generated a graph like you saw, the two previous examples. And so this behaved a bit like sieves, if you will, like tamises, with big grain on top, small grain at the bottom. Big grain is typically DNS checking. Small grain is typically, do we have security updates, you know? And there's interdependencies between the tests. Unfortunately, or not, because as I said, the tool was not really beautifully architectured. I don't think this tool had a future. It still has a future probably in the company, but I don't think it will be open source at any point. And since then, since probably, I would say at least 2010, I've been thinking of a way to re-implement this in a cleaner way, in a more dynamic way, in a more pluggable way as well. Something that wouldn't be linked so much to your architecture, that wouldn't depend on MySQL, that wouldn't, and that wouldn't be in Perl if possible. I've been thinking about it for quite some time, and then last year, I started working on a project that was mildly going in this direction. The idea was to add specs to Puppet runs. Who here has never heard of RSpec Puppet? Yeah, you'll know about RSpec Puppet, maybe use it. RSpec Puppet is made specifically to test catalogs, but to test catalogs in a very secluded, in a very clean, extracted from production environment. And the whole idea is that in RSpec Puppet, you generate a small catalog from a bunch of classes, and this small catalog you assert using RSpec. Now the idea of Puppet-spec was how about plugging this into the actual catalog run, into the actual master-agent communication. So instead of being unit test, I still call it unit test, but instead of being unit test, it's more like a check, you know, like this guy at the airport that checks you before you board. It's more like this, you know. The agent receives a catalog, and before it gets applied, you actually want to check that it's fine, that it's ready to go. And if it doesn't pass the test, you will refuse to apply the catalog. And it's quite interesting because, as I said, when I was showing the slides this morning, I got a comment that there's actually another project that does this. I'll just show you the link because I didn't put it in the slides. Here. Yes. It's the Puppet Policy Compiler. Has anyone heard of this one? Yep, cool. I didn't know about it until this morning. And it's pretty much what I've been doing in Puppet-spec. And the funny thing, as I said, it seems these IDs that are floating and different people catch them at the same time. The funny thing is that I just saw that Hannah started working on it in April 2013, and I started working on mine in March 2013. So we pretty much had the same idea at the same time, and the implementation is really similar. So after learning about this morning, I think I'll have to talk with Hannah about this. But that's only one side of it. The second side was also testing the state of the machine after the catalog was applied. So like I was saying before, and this gets closer to the idea that was in Treetester, in this tool that I had in my previous job. Let's pass this. So Puppet-spec is a module that provides Puppet indirectors. So it plugs into the catalog fetching, or it plugs into the report sending for Puppet and replaces these pieces. And the whole idea is to run tests from within the Puppet runs, either to check the catalog or to check the state of the machine after the catalog application. And so the catalogs are tested using RSpec Puppet because the matchers that are provided by RSpec Puppet really fit the need. It just doesn't use the whole RSpec Puppet engine, just the matchers. And the host is tested using serverspec because that's what serverspec is for. So if you use everything in Puppet-spec, it would go like this. First, the catalog is compiled on the master, and then there's unit tests that will check the catalog, either on the master or on the agent side, as I will show. And then the catalog is applied if the test passed. And once the catalog is applied, there's the functional tests that are applied. And if the functional tests pass, great, it will send the report and everything's fine. If the functional tests fail, it will amend the report to say that it actually failed, add the information about the test that failed to the report, to the logs, and send it to the Puppet master back. And as a result, Puppet still applies everything, but in your favorite report manager, in Forman, Dashboard, Puppet Enterprise console, you will see the machine as having a red status, a failed status. And some people told me, well, that's kind of problematic, because then you have a failed status for two different things. There's actually a failed status for two different things already, so that's three different things now, because there's already a failed status when the catalog fails to compile, and then the machine is not touched at all, or when the catalog fails to apply, and then the machine may be broken. So that's just a third state for this failed status. So the unit testing side of it would go this way. It can be used either on the master side or on the agent side. There's pros and cons of each. I'm waiting to see if people use it, how they would like to use it. I started to code the agent side actually first, and the reason for this is that I wouldn't break production while I was coding. That was the simple reason. But both are available. And so you simply have RSpec Puppet matchers. So it looks very similar to what you used to. It should contain package Puppet. It should contain package Puppet. I just put this to make it crash to have some tests. It should include class Puppet. It should include class Puppet client base. The little bit of a difference is that the catalog is exposed by calling Puppet-spec, calling catalog.instance.catalog. And what this does is that when it's running in the catalog indirector, it actually retrieves the catalog and exposes it as the subject so that the matchers can actually access it and assert on it. With this type of code, when you call the Puppet agent, with your usual command Puppet agent -t, it will call the master, and once the catalog is compiled, it actually runs the test on it, and you will have something like this. If the test failed to run, you will have the output this way. You could not retrieve catalog from remote server, just as if the catalog had failed to compile, actually. As far as the agent is concerned, it's the same kind of issue. Unit test failed with the unit test in the output. So here in this case, it should contain package OGS, and it actually doesn't. And it tells you that it actually failed in the packagespec.rb test on line 3. And the result is here down there, you see not using expired catalog from cache, expired, blah, blah, blah. If there was a catalog in cache that could be used, it would have used it. It's just as if the catalog compilation had failed. So it's not so much unit test as I was saying, it's more like a last check before boarding, if you will. And we'll love this when we're at the airport and we get checked all over the place, right? Now the second part of it is how do we deploy these things? Oh, I see that my text is like getting out of the slide actually. How do we deploy these things? On the master side, it's pretty simple. There's no need to deploy because it's already on the master. So when the catalog is compiled, before sending it to the agent, it just runs the test. The tests are local, no need to deploy them. So on the master side, what I've chosen to do is to put them in a spec directory that's directly above the manifest here. So that would be the environment directory, pretty much. So in the environment directory, you will have a spec directory with a catalog subdirectory and a class subdirectory. And in there, you can put this RSpec test. Now, I've really struggled to decide which test to apply to which machines. Because obviously, I'm applying to production, so I'm not actually faking an environment. what I've chosen to do, which is maybe the influence that CF Engine had on me over the years, was to use the files that were in the directories named after the classes that were declared. So what this end directory will do, actually, is that it will list all the classes that are declared for this host, and it will check in the directory if there is a directory under the class directory that is named after this class, and if there is a directory with this name, it will add it to the list of directories that are sent to RSpec for the test. So every subdirectory under spec catalog class that is named after a class that you have declared in your catalog will be used to run the test. The system is quite similar on the agent side. Obviously, we can't deploy the test using file resources because the tests need to run before the catalog application. So the best way to deploy something before the catalog is actually applied is using plugin sync. That's pretty much the only way to do it in a Puppet-ish way. So you can deploy the test using plugin sync, and in order to use plugin sync, it needs to go in the lib directory. And because you can deploy anything you want in Puppet in this lib directory using plugin sync, it goes into lib spec catalog class. So the same kind of hierarchy than on the master, except it's in the lib directory of any module. And again, on the agent side, it will take the list of all the classes that are declared in the catalog and check for directories with this name under the spec catalog class directory in the libdir directory on the agent. So it's quite similar whether you're on the master or on the agent. It's just a little bit more simple on the master, but on the other side, it's centralized. It's all in one directory in your environment directory instead of being in each module. There's obviously limits to this. Currently, when to apply the test, like I said, I chose to use the class names. There may be some better ideas to do this. I haven't thought of another idea to actually target the test and to say this test should apply to this machine under these conditions. To choose whether to test on the master or to deploy all the tests, knowing that if you use plugin sync, you're going to deploy the test for all the classes, all your agents, on all your agents, which can be a bit heavy. You end up with all the tests on all the agents, just like plugins. And redundancy, obviously, the syntax is a little bit different because you need to access the actual catalog instead of actually using RSpec Puppet, which creates a catalog and exposes it to you. So it means you need to rewrite the test currently, and obviously there's a huge redundancy between the test in the modules and the test that you actually apply to check your catalog before applying it. So this is still a question. Is this additional security, and is it okay to have redundancy, or should we use the same tests as the tests that are in the modules, and if so, how to plug them, how to decide when to apply them? I don't have an answer yet. This is still something that's open, and I'm clearly open to new ideas about this. How do you set it up? You'll find if you have looked at the Puppet policy compiler that it's very similar, because that's probably the easiest way to do it. Like I said, it plugs as indirection termini. And these termini are deployed as plugin sync also. They're deployed as plugins on the agents or on the master. And in order to set up this termini, you need to modify root.yaml. Just be careful if you do this on the master. If you're using the PuppetDB module, it probably just considers that it's the only one modifying this file. So it provides the whole thing as a template. So it tends to replace it. So this roots.yaml file, if you haven't played with it before, it tells Puppet where to find the terminus for each of the indirection terminals in Puppet. So for example, here we're saying that on the agent, for the catalog, it needs to use the respec terminus, which is the one that is provided by the module here, which pretty much inherits the rest terminus and overrides it in order to run the test. And then and then for the cache, it uses YAML. On the master, it's quite similar with the compiler spec, which replaces the compiler terminus. Obviously, I'm giving you the two examples here. it only makes sense to use one of the two and not the two at the same time, especially on the same machine. So this is the first part, the part about actually validating a catalog before applying it. The second thing that this Puppet-spec module does is checking the state of the machine, the state of the machine after applying the catalog, so whether the machine complies with a policy. And this policy would be written using serverspec, because serverspec is also a set of matchers that have been specifically written to test the state of the machine and not to test the catalog like our spread Puppet. And we want to actually check the state of the machine. So if you haven't used serverspec before, this is what the language currently looks like. You describe types of resources like service, port, file. You could have packages as well. You could have a lot of different things. So here we're describing service HTTPD and saying that it should be enabled and that it should be running. If you've been to the talks about Beaker, for example, this is not new to you. Serverspec has several backends. It has the SSH backend, which was historically the default one, which was really frustrating to me when I started using serverspec, because I'm like, come on, it's 2013, and we're talking about orchestrating stuff over SSH. I mean, I think there's something wrong. So at the time, I started contributing to serverspec and provided the exec backend, which is now used quite widely, and the Puppet backend, which unfortunately has been removed by the serverspec authors because he didn't see the point in using it. The whole point of the Puppet backend was not to interact with Puppet to change stuff, because there's not much of a point when you're doing testing, but just using the Puppet resource abstraction layer to actually test the system, because all the abstraction is already there for pretty much most of the operating systems we want to manage. So I didn't see the point in recoding everything with Bash, but apparently that wasn't his opinion. So currently, when you install serverspec, you get the choice between two backends, the SSH backend and the exec backend. It's still frustrating to me, because I'd like to be able to test the machines remotely, but not over SSH, because it's just not. I have clients that are behind NAT somewhere in the middle of, I don't know which country even, and I don't have direct access to the machines during using SSH. And besides, I don't want to have to run the test one by one on all the machines. I would like to parallelize the thing, because I don't have all night to do my test. So we'll talk about this afterwards, actually. So the functional testing part of Puppet-spec just plugs in this serverspec, or actually spec infra, now that it's actually separated. Spec infra provides the matchers, and serverspec is the whole language. Sorry, it's not this. Sorry, spec infra provides the methods for testing, and serverspec provides the matchers for our spec. And it tests the machine and not the catalog. So this is just the same example I had before. You just drop in the thing, deploy it, and Puppet will run this serverspec test at the end of the catalog run. So here's an example. Here I'm running with Puppet agent -t. The catalog was actually validated. Maybe I haven't activated the indirector for checking, or maybe the test passed. So you see here that the catalog is actually applied. I put applying changes. This is not the actual output. It's just to make it shorter. And then it finished the catalog run in 59 seconds. And it could not, well, sorry, this is an old output, actually. I should replace it, because it actually sends the report nowadays. But it tells you that the unit test failed at the end of it should be actually functional test. I think this is an old output, like I said. The test failed at the end of the catalog application, and you can see the failures, and the failures are actually serverspec code. So it says the OGS package should be installed, and it actually wasn't installed on the machine. Or the user share OGS lenses dist should be a file, and it wasn't there, and so on. And what this will do actually currently is that it will tell you this, and it will add this thing to the logs in the report and send it to the Puppet master. So in order to deploy this test here, we actually have the choice. They're run after the catalog application. So you can either deploy them using plug and sync, just like the other test. and they will be deployed before the catalog application. Or you could use a file Puppet resource. I'm providing a spec, serverspec define resource type for this, so that it puts it in the right place. It's really up to you. It doesn't make a difference so long as it gets deployed. So once I had this, I still wanted to be able to do this functional test remotely. So this module also provides an MCollective agent. And the MCollective agent actually maps directly to spec infra. It actually doesn't use serverspec. It just maps to spec infra. And what it does is that it sends actions and values to spec infra check comments, and it returns true or false. So it uses MCollective as a transport, which means that from MCollective, you can use the MCO client and use MCO-RPC spec. So you're contacting the spec agent remotely. The action will be check, and then you send an action and a value. And what it will do, for example, if I run MCO-RPC check, MCO-RPC spec check, action equals user, value equals Pinson, for example, it will actually contact all the nodes that have the spec agent, obviously, and run the check user method of the spec infra library with value Pinson. And this will return true or false. So this is what you will get in the output, actually. I'll show you an example in the demo at the end. As an output of this, I just cut the output here to give you the different examples. But as an output, you will get true or false for each of the machines that were tested. Once I had this agent, I was getting as close as I thought I would get so far to re-implementing this tool I showed you before. So I could actually test things remotely in a way that I could orchestrate functional tests on my machine. So the next step was making this tool that I call Mspectator, which is pretty much a set of RSpec matchers that will use MCollective as a transport to run the test remotely on your machines. And it uses, among other things, actually the spec agent. It can use other things. I'll just show you an example. But first, the architecture. The architecture of Mspectator is pretty simple. So you have the client, which is on the side where you have the MCollective client, the MCollective RPC client. It doesn't use the MCO command. It just uses the Ruby interface for this. And so you write your test in RSpec, and when you run with RSpec, it actually uses the MCollective RPC client, sends the action and the arguments to the action to the spec agent on the servers, and the spec agent will call the check action in the spec infra library and actually check if it's true or false, if the assertion is true or false, and return true or false. And then in RSpec, this true-false assertion will be used to actually decide if the assertion in RSpec passes or not. For the syntax, I was kind of really frustrated by serverspec, because serverspec uses describe everywhere to describe packages, services, and everything. And what I wanted to describe were machines, were hosts, nodes. So I implemented a different set of matchers that actually do not correspond to serverspec matchers, which is OK, because I'm just using the spec infra library, not the serverspec language. So when I use describe here, I'm actually describing a Puppet class, which will filter the machines that are discovered by MCollective. So here I'm describing all the machines that are classified with the Apache class on my infrastructure. And then the test actually tests all these nodes. So here's one test I have here. It should find 100 nodes or less. It should pass Puppet-spec. It should have certificates .signed. And this test uses different backends, pretty much. The first one is pretty obvious. It's very simple. It should find 100 nodes or less. This simply counts the nodes that were found by MCollective by just running a discovery on the Apache class and saying, well, if there were more than 100 nodes, then it doesn't pass. If there were less than 100 nodes, it passes. The second one uses the spec agent with the run action. And what it does is that it will run the functional tests that were deployed by Puppet as in the reporting director, and it will run exactly the same tests that were deployed and run after the catalog application and check if it still passes. The third one actually uses the Puppet CA agent for MCollective to check if those machines were signed. And you can imagine that you can plug other things in there. It should be backed up, for example. You would have a backup agent on some backup machines that could return if the machine is backed up or not using a call to MCollective. And then you can also filter a little bit more. So for example, here I'm saying I only want to test the Debian machines. And so when on Debian, with the facts operating system equal Debian, do, and so on. And so I'm actually using the context here with this facts array. I could also filter with mode classes to actually restrict the number of nodes I'm testing. And again, you have a similar syntax, except here you have a syntax that will actually use the spec agent with spec infra in the back. So for example, it should have package Apache 2.2 common. Will actually send an action on all the machines that were selected, checking if package Apache 2.2 common is installed, and it uses spec infra for this. So spec infra, again, returns true or false, and this actually makes it pass or not. The output, I had to truncate it quite a bit here. It looks like this. I didn't put the colors. So when testing the Apache class, it should find 100 nodes or less. It should pass Puppet-spec, and you see that it failed. And here, let's look at one of the failures here. It should pass Puppet-spec. It actually launched the spec on all the machines. And there's 2 of our machines that didn't pass the test. So here, there's no output. I don't know why. I think I truncated it from the output here. But otherwise, you would have the output from actually launching the functional test, and it would tell you why these machines didn't pass the test. The same would happen with other things. For example, if I expect that a package would be installed, it will actually run in remotely and then tell me, give me the output from our spec, which made it fail, and for which machines it failed. So obviously, this means that currently, I don't know if this is the best interface for the tool, because obviously that can get quite long if you have 100 machines to test and 100 of them don't pass. I'm done with the slides. I want to use the last few minutes I have. I have 2 minutes to just do a little demo and a few questions. Here. So here, I have a few machines. I have a master here. I'm on the master. And I have a few other machines. So it's running Puppet Enterprise. And logged in as P and min, I can actually ping my machine. So there's 4 machines if the 4 are willing to answer. I don't know what's wrong. I'll show you first how it goes with the integration in Puppet. So here, let me find my notes again. I'll show you the code itself. So if I go into my modules, if you use to Puppet Enterprise, it's in etc Puppet Labs Puppet modules. And in there, I made a policies module. And in this policies, I have a libspec directory. And in libspec, first, I can look at the catalog specs. So here, there's a catalog class with MCollective, which is what I want to test in this case. And so it means that it will only test the nodes that have the MCollective class classified. And the name of the file here doesn't have much importance, call it mcollectivespec.rb. And so here, sorry, I'm retrieving the catalog using Puppet-spec catalog.instance.catalog and checking that it contains package MCollective and contains the service PEMCollective, which is actually should be fine. So if I go on Gonzo and run this, I'm running Puppet agent, and Gonzo has actually been configured to use the indirector on the agent side, and this is what I get. It actually didn't work because it says it should contain package MCollective, and obviously PEMCollective doesn't install MCollective, it installs the PEMCollective package, so it failed. And so the catalog was not applied on this machine because it failed the test. This is the first example. If I show you the functional examples here, in the same directory, I have a server directory. And again, it's also filtered by class. And I have an MCollective spec, and this time it's a serverspec language. So I'm describing the expected state of the machine. I expect that PMCollective should be installed, PMCollective should be running and enabled, that this file should be a file. And here I have two tests that I expect will actually not work. I just put the comments here. Obviously, it's a bit stupid to have the comments in here if I know that it's not going to pass. So it's just to show you why it's going to fail. Port 61.613 should be open. Actually not. It shouldn't be listening on servers, only on, it should only be listening on the active MQ machine. And this should be a file, and it's actually not true. So if I go on, let me see, which one is it? Kermit here, and run puppet agent -t. Here it retrieves the catalog. It will actually apply the catalog because there's no tests that are failing here for the catalog. But then after the catalog is applied, it generates errors because the port is actually not listening and the file is actually not present. If I go on the console here, you can see that these nodes actually failed. And I can have a look if I'm logged in. Yeah, here I can have a look at the report, and the report actually contains the test. It's not really beautiful, but you can actually see that it's the functional test that actually didn't pass. Finally, I'd like to show you this Mspectator thing. Where am I? The master. So, as you know, if you're used to Puppet Enterprise, I need to be p-admin. If I run this kind of actions, mcrpc check, spec check, I'm actually contacting machines and asking if user p-admin is actually present on the machines, and I get false or true depending on the machines. And then finally, I can use these things to actually write specs using Mspectator. So I need to use the Mspectator gem, and I'm actually testing all the machines that have the PMCollective Puppet class, expecting to find 5 nodes or more that they should pass Puppet-spec, and that if they're on Ubuntu, they should have package PMCollective. Now, if I run this thing, I'm sorry, there's going to be ugly output because of RSpec 3. So here you can see that there's some tests that don't pass here. I can scroll up a bit, quite a bit, because of RSpec 3, and see which ones didn't pass. So you see that this one passed, the 2 first ones didn't pass, and here it says, should have found 5 nodes, but it actually found 3. It should have passed Puppet-spec, but actually Puppet-spec didn't pass on Gonzo because of the 2 errors that we actually saw when we ran the functional test on Gonzo. So this is it. Just a bit like Gareth, I would like to know this is still a proof of concept. It's not in production. It's just ideas I'm throwing in. I'm just really interested and excited when I heard Gareth's talk this morning that he had the idea of actually auto-generating the serverspec test based on PuppetDB. And I think we could actually generate this test based on the catalog instead. And if we run it after the catalog run, it would be pretty easy to take the catalog and say, well, if there's a package in the catalog, then we should have a serverspec test that actually checks for this package. And we could run the test automatically after Puppet applies it to actually check that the result is what we expected. A bit over the time, I think. I don't know if maybe I can take maybe 2 or 3 questions if people have questions. Do you have any questions on this? No questions, sorry. You can come and talk to me afterwards if you have questions. Thank you for your attention.